Part 2 of Lesson 7 of Chapter 4 is more on the law of signs. So I want to go over the law of signs, especially the ambiguous case. The law of signs simply says the sine of angle A divided by length A equals the sine of angle B divided by length B divided by the sine of angle C divided by length C. So you can use this proportion to solve for missing angles or missing side lengths of a triangle that is not a right triangle. So the ambiguous case is when you're given two sides and an angle. Sometimes you're given two sides and an angle and you cannot form a triangle with that given information. Other times you can be given two sides and an angle and you can make exactly one triangle from that information. And other times you can be given two side lengths and an angle and there's two separate triangles that you can form with that given information. So here's an example where two triangles can be formed. This is a side-side angle case. And so the only thing we can solve for to start this problem is angle B. So we start off using the law of sines and say the sine of angle B divided by 28 has to equal the sine of 43 degrees divided by length 25. So we're going to have to cross multiply and divide. We'll take 28 times the sine of 43. And then we'll have to divide by 25. And in doing so, we get 0.76. But this is equal to the sine of B. So now we'll have to do sine inverse of that 0.76. And that gives us 49.8, so we're going to round that off to 50 degrees. But since two triangles can be formed, that's only one of my angle B's. I'm going to use subscripts, B1 and B2. So if B1 is 50, B2 is 130 degrees. So there's your two possible measures for angle B. Now we have to find our two possible measures for angle C. So to find that, now if we take angle A and add B1 and add C1, that should give us 180 degrees. So 43 and 50 degrees gives you 93. Subtract that from 180 and you get 87 degrees. Now angle A plus B2 plus C2 has to add up to 180 degrees as well. So if we add 43 and 130, that gives us 173. And so angle C2 is 7 degrees. There's your two possible measures for angle C. Now we need to find the two possible measures for length C. So to find that, we'll have to use the law of sines. And to find length C1, we'll use the 87 degrees. So the sine of 43 degrees divided by 25 has to equal the sine of 87 degrees over length C1. Cross multiply and divide. We got 25 times the sine of 87. Divided by sine of 43. And that would give us 36.6, rounding that to the nearest tenth. And now to find length C2, we do the same thing we just did, except for I'm going to use the 7 degrees instead of 87 degrees. Let's go up here and fix this to 7 degrees. I had written 7 squared for some reason. Okay, so the sine of 43 degrees divided by 25 equals the sine of 7 degrees divided by length C2. Cross multiply and divide, we take 25 times the sine of 7 divided by the sine of 43. And that gives us 4.5. So these are the two sets of information that complete this triangle. Now, if this doesn't make sense to you, I'll try to take this triangle and, you know, length A is 25 that you can see. If we were to swing that this direction, it would still be 25, but your angle C would change from, you can see that this right here represents 87 degrees. And then, let's use this color. This angle right here represents the 7 degrees. Here's maybe a better picture for you guys to see. There's the two triangles. You can see the original one with the dashed lines and then the second triangle with the solid lines here. And here are the specific measures of those angles and those side lengths. Let's do one more example. We have no picture for this, so I always like to draw myself a picture, even though it might not be drawn to scale. They're telling us that angle A is 38 degrees. They're telling us that length A is 8, length B is 10, and we have to solve for the missing angles and the missing length. So the only thing we can solve for to start this problem is angle B. So the sine of angle B divided by 10 has to equal the sine of 38 degrees divided by 8. Cross multiply and divide, we take 10 times the sine of 38. Divided by 8. And we get 0.76. Then we have to do sine inverse of that 0.76. And that gives us 50.3. I'm going to round that down to 50 degrees. Which means that the second angle would be the supplement of 50 degrees. So there's your two possible measures for angle B. Which means we have two possible measures for angle C. So let's see here. 50 plus 38 gives us 88. If we subtract that from 180, we have 92 degrees. And let's see, 130 plus 38 gives us 168. So angle C2 would be 12. Now to find the two possible lengths for length C, we'll use the 92 degrees first. So the sine of 38 degrees divided by 8 equals the sine of 92 divided by length C1. Cross multiply and divide, we'll take 8 times the sine of 92. Divided by the sine of 38. That gives us approximately 13. And then to find length C2, we'll do the same thing, but we'll use the 12 degrees instead. And so cross multiply and divide, we take 8 times the sine of 12 degrees, divided by the sine of 38, gives us about 2.7. So there's two examples of the ambiguous case when two triangles can be formed. So we're going to talk about the area of a triangle. So if you're given side, angle, side, that is two sides of a non-right triangle and the angle in between those two sides, you can use one of these formulas to find the area of that triangle. So here's an example. You can see this is side, angle, side case. We're given the two sides and the angle in between. So to find the area, we use the formula. 1/2 times 10 times 7 times the sine of the angle in between. And so if we go to our calculator now and type that in, and my angle is 108, gives us the area, which is about 33.3. Label that as square centimeters. Pretty simple formula to use. Again, you just need to be given two sides and the angle in between to use one of these formulas to find the area of a triangle that is not a right triangle.